Hello, everybody, and welcome to the live stream. Thanks for joining us today. Today I'm joined by my friend Paul. Paul, do you want to introduce yourself?
Hi, my name is Paul. I am currently a compiler intern. Looks like I might be continuing to do more stuff with compilers after this. Yeah.
Wonderful. Well, thanks for joining us, Paul. Now, if you know anything about me and you've seen some of the last videos on this channel, you know I also really love compilers and I've been working with them for a few years. And so when I met Paul, we pretty much immediately thought of a lot of different interesting projects that we could work on. And today we're going to be building one of those projects. This one is one that we like to call RedVM, code word that we came up with for the project. And the basic idea is that we are going to build a compiler that can turn high-level code into Minecraft Redstone. I'm sure you've seen a lot of different projects online around people making calculators or computers even using Minecraft. I know there's one project where they built a CPU and GPU fast enough in Minecraft with a custom Minecraft server implementation that runs Redstone something like 10,000 times faster than like vanilla Minecraft server, and they were able to run Minecraft on the Minecraft CPU and GPU. So yeah,
Yeah,
people have
I
done some
saw that.
crazy
Yeah,
things.
yeah.
Yeah, people have done some crazy things. As a matter of fact, there's even a feature tag you can enable for that server that will JIT compile the Redstone circuits. So people get really crazy with the kinds of compiler tech that they can throw into Minecraft sometimes. Um, but today we are going to be effectively doing something, I guess, a little bit different. We're not really building a specific computer or like, graphics card or whatever in Minecraft. Instead, we're going to build programs that can compile code into Redstone circuits. And so instead of a computer in Redstone that you'd then be able to write a program for, we're going to try and output an application specific circuit, almost like an ASIC generator or compiler from high level code. So I'm looking forward to doing this. I think it's going to be really fun. A question for you, Paul. Why did you think this was a fun project to work on? Why do you think we should do this?
I think it's a fun project to work on. I don't think there's any good reason why we should do this. There's no real use case, other than it's good educational content. We're both probably going to learn quite a bit throughout this process.
Right.
I think the thing that I find most interesting is just the idea that there isn't a fixed chip that we're compiling for. And as you mentioned, we're basically going to be creating the circuitry required, and that's optimal for any given program that it was given. So that's something you can't really do in real life yet. So might as well do it in Minecraft.
Yep. Well, maybe we have to work with FPGAs one day. We'll see. But no, this is basically the equivalent of that without needing like a physical FPGA. Or like I guess this is even different because we're not even changing the gates on a chip. We're just building the chip. Anyway,
Yeah.
it's a really interesting project. And I guess let's get started. So the basic idea, we already have a little bit of this planned out. The way I see this going through is in sort of three phases. We're going to start off with a lot of the bare bones infrastructure that we need to get redstone to be generated to begin with, right? So let's put in the building blocks to be able to generate redstone for arbitrary circuits. Then we'll put in all the building blocks for enabling that redstone to be composed by higher level logic. And by higher level logic, I mean assembly level. So even assembly level is going to be high level for this project because once again, redstone is kind of the equivalent of electrical like wiring in real life. So if we were dealing with an analog circuit, right, assembly is very high level compared to the actual circuitry. So first, we need to put together the mechanisms of being able to generate circuitry, the mechanisms of being able to take high level logic and turn it into circuits, and then the logic of being able to turn a high level language into that high level logical language that we can then turn into a circuit. So we're going to work from the bottom up here and learn as we go, obviously. So I guess let's talk a little bit about architecture. So on a high level, I'm going to share my screen here so we can potentially like diagram some stuff out. And also, by the way, as we go ahead and stream, if anybody has any questions about the process or what it is that we're doing, feel free to put it in the stream chat, and we're glad to answer your questions, or even if you have any ideas, if maybe we're missing something. So yeah, feel free to put that in the actual chat. Let's get started. So the way I see this starting out is with one component to begin with, and this component is going to be the one that deals with um, effectively being able to define a redstone circuit. So every time we want to prototype something, I don't think we would want to um, actually for lack of a better way of putting it, like actually go into Minecraft and generate, like actually put redstone down manually all the time. We want to automate that eventually, so we might as well automate that now and make it so that we can more efficiently output redstone circuits using a custom language. So that's where I imagine we would start. Do you want to talk a little bit about what you think we would do for that, Paul?
Right, yeah. I mean, besides prototyping and everything, we'll probably need a lower representation of the redstone that we're generating anyway for our compilation process. So what we discussed while talking about this whole project is this idea of this RCL language, which would be a redstone circuit language. And the idea is that this abstracts away all the I guess what you call primitives of redstone circuits. So things like redstone wire, torches, heaters, all that stuff would be kind of the primitive type that make up this redstone circuit language. Now, this language is very bare bones, very minimal. There's no such thing as like branching or functions or anything like that. It's not sequential technically because
Yeah,
we define the locations of those primitives inside of like bounding box of the circuit that would then be rendered into an actual Minecraft world.
right.
So yeah.
It, yeah, I guess it would practically boil down to like a language that defines literal redstone wiring in Minecraft. So
Yeah.
not like logic or anything.
Yeah.
And then the advantage of doing this is twofold. First of all, we now have a language that we can export into Minecraft, so we can like define a redstone circuit, export to Minecraft immediately without having to place blocks and break them or whatever. Additionally, we now also will have the capability to simulate redstone without needing Minecraft.
Yeah.
So every time we want to check the validity of a circuit to make sure it does what we want it to, we don't need to load up a whole Minecraft world. We can just do it in our little simulator as long as it's a good simulator. So I guess in terms of like what components we would build. We need to build the export functionality for this tool, and we would also need to build the simulate functionality for this tool. So that's what I envision the RCL needing, like so. Then from there, once we have RCL finished, we will need to have higher level abstractions. Because now that we have the ability to define what a circuit looks like, we then need to be able to define how high level logic turns into that circuit, but that's going to be our next step.
And just keep in mind at this point, we haven't even discussed what a gate is because we're actually one step lower than that. We are talking about just redstone primitives. So the next step that Tame just mentioned would be where we actually define what an AND gate is, for example. When he says higher level abstractions, he doesn't mean like stuff that you get in a regular coding language. At this higher level abstraction that we call RLL, Redstone Logical Language, the idea is of like branching or functions or all that stuff still it does not exist. It's just now we have gates.
Pretty much. It's still a raw circuit, but now we have like gates that we can use and like maybe like memory cells or something. But it's still very much a raw circuit.
Yeah.
It's just pretty much the only thing it abstracts away is the fact that we're doing it with redstone, right? So instead of using terms like redstone wire and redstone torch and stuff, it's like you would use gates, and then we would figure out how to make a redstone circuit from those gates. But it's still just gates. And then we would build even further on top of that, and we haven't really decided exactly what this looks like. But either we would then extend the logical language to support genuine higher level abstractions, or we'd build yet another language on top that turns into the logical language. So we're still discussing that bit. But all of these pieces of logic are going to exist at the bit level / wire level. So we're not talking about byte level abstractions or data type level abstractions. We are talking about quite literally logic that works on the individual wire, the individual bit. So that's what we're talking about right now, and this is sort of what I have in mind so far. Do you have any other like ideas?
I don't think I have anything to add right now, no.
Wonderful.
So
Okay.
it's a good overview of what we had discussed for our starting spot.
Right. So yeah, this is pretty much all the two of us have in mind right now. And so, by the way, all of this development is going to be open sourced after the live stream, so feel free to contribute. I know, a couple of our friends might pitch in and join the live streams in the future as well. This is a many-part series, so we're gonna have a lot of fun along the way. But yeah, I guess we can start off. And so I guess the two things that I know need to be done right off the bat is or three things even. We need to define and agree on like syntax for RCL, what it looks like. We need to agree on the way we actually export it to a Minecraft world file, and we also need to build the parser for RCL. So that given RCL in a text form, we can parse it into an internal representation and then generate a world file from it. So I guess let's get started. What part do you want to start with? Maybe syntax?
Yeah, I think we have to start with syntax really. Otherwise,
Wonderful. Okay, so I'm SSH'd into our shared environment here. Nothing here. Let's create like an example RCL file. Extension RCL. Unfortunately, GitHub Copilot can't help us because it's our own language. Let's see. So, what's a simple redstone circuit? Let's just imagine something like an AND gate, right? AND gate. Let me remember how that would be defined. This shouldn't be hard to remember, but it's
gonna Google picture.
Yeah,
of,
yeah.
AND gate
Agreed.
in Redstone.
Agreed. Let's see, redstone AND gate. Yeah, okay. Let's see. That seems like it's overly complicated.
There's way simpler ways.
Yeah, right there.
That's the
Is
one.
that it?
Yeah.
Okay, wonderful. Wait, isn't this an OR gate?
No, OR gate, you don't need.
Oh, right, sorry. There's the torch at the end there. Yeah, that's what makes it an AND gate. Perfect.
Yeah.
Okay. So yeah, as long as either one of them would be turned off, the power would turn the middle redstone torch off, so that makes sense.
Yeah.
So in order for something like this to be represented in RCL, if we wanted to do it, we need a few things. We need input nodes, we need output node. We also need the ability to place an individual block with redstone on it and with torch, which is something I hadn't thought about, because the way I was thinking of it is that we would have different abstractions, like we would have the ability to place a block with redstone dust on it or a block with a redstone torch in front of it. But now that I think about it, in order to represent things like this, you need to be able to say the block has two modifiers. So the block needs to exist independent of the fact that it exists with redstone dust on it.
Yeah.
Yeah.
What if okay, since we're gonna have locational information about every component in RCL, right?
Right.
And if we just treat every component as its like raw component type here, and then just have like an additional attribute for orientation or stuff like that for block types that have multiple things going for it, you know?
Right. And so what we would do is we would have individual block types.
Yeah.
And then what we can do is say that certain items, I guess we would call them, certain items cannot exist independently in space. They need to be attached to a block. So things like redstone dust or redstone torches need to exist as I guess, quote unquote, instructions in this language, with an attribute of which block they attach to and where on the block they attach to it.
Right.
Right. And then in validation, we can do things like make sure that two things don't assume that they're on the block on the same thing at the same time.
Right. Yeah,
Right.
that makes sense.
So that would do it.
Now, I briefly mentioned this earlier, but when we're talking about defining like an RCL file for an AND gate or something like that, is there any sort of sequential thing we need to keep track of, or is this like almost like orderless what order we put the instructions in?
It's pretty much orderless because the order would be defined by the quote unquote execution of the redstone.
Right.
Order wouldn't. RCL is a placement first language,
Yes.
not an order first, and the order is the execution of the redstone. So we can shuffle around instructions however we need to theoretically, but I guess RCL is just like a very raw representation, so we wouldn't really need to do anything. Okay, so now that we have that logic, I guess, decided, let's see what types of blocks we need. So what are all the like redstone related blocks in Minecraft?
I don't know. I don't think we need. Well, actually, I'm not sure if we would need to support all of them. Like, I
Right.
can't imagine like a need for a piston or something
Right,
given
right,
our use case,
right. That's a good point.
unless we want to provide like some crazy IO runtime libraries.
That would be a very interesting extension of the language.
Yeah.
So maybe we'll note that down for like part 30 of the series.
Somewhere around there.
um, okay, let's maybe ask ChatGPT. Funny enough, maybe that's an easier way. What are the redstone components in Minecraft that would be relevant to putting together logical circuits? Let's see what it says. Um, because I just don't want to make sure that I just want to make sure that we don't miss anything. Because there's the obvious ones like these, but maybe we're missing something. Because I know we're gonna need input and output nodes as well. And those input and output nodes will probably be like levers and redstone lamps, from what I can tell.
Yeah, for now, that's probably all we have to worry about.
Right.
Want to keep things simple to start off.
Agreed.
Redstone blocks.
I don't think we need those.
We need to find out what like the most minimal
Subset of
yeah,
these is,
yeah.
right? So I'm thinking just dust, torch, lamp, repeater, and lever. That should theoretically be enough. Maybe comparator.
Comparator would make our lives a lot simpler.
Yeah, agreed. For things like clocks.
Yeah.
Yeah.
Are you sure you don't need a block? Like redstone block ever?
I do not believe we will. Worst case scenario, if we do, it shouldn't be a hard language extension.
Yeah.
Right. So,
Yeah.
because it's just another block that would be placed somewhere. So theoretically, that should be our set. So let's also figure out in terms of syntax how we put comments. Do we want comments to be like assembly type, where it's a semicolon, or like a slash slash or a hashtag, or what's your
Okay.
opinion?
So I'm of the opinion that since we want RCL to basically be like an IR,
Right.
and well, okay, so we had a conversation about this actually. Because we're dealing with locational data inside of RCL, there's no way to convince me that RCL is user friendly by any means. And ideally, we would have another.
Well, I
stage
mean, we
above
don't necessarily need to do direct locational information, I feel like, as much as we would just need to make it so that at least relative locational information
it.
exists.
Right. But I mean, like,
But like not even
defining
explicitly.
any offsets by hand.
But it doesn't need to be like a numeric offset. It could be like this wire attaches to this wire in this orientation.
Oh, we're gonna do that?
Right.
Okay.
And then it could just like we can calculate the offsets based off of like a root point.
Okay.
And so it's like somewhat user friendly.
Okay. I was gonna argue that we do like LVM IR style comments if we're going for something that is.
The IR style comments with semicolons, right?
I believe so.
Let's go with semicolons then.
Okay.
Yeah, it feels right for this kind of
right
language.
because it's
Yeah.
that low.
Yeah.
You know?
Right.
Yeah. Okay.
So this would be like a comment. So we could so it's just the types of items would be we have redstone dust. We'll support redstone torch. Redstone repeaters. We'll also want comparators, as well as, let's see here, levers for input.
Lamps.
And lamps for output. There we go. Okay. So do we abstract these into other names, like for example, wire, or like for example, power, and maybe extender, or do we just use the names dust, torch, repeater?
I think I prefer the raw names
Agreed.
considering this is like
Supposed to be
it
super
is
low
what
level
it is.
Minecraft.
We're
Yeah,
not
agreed.
abstracting away what a piece of redstone dust is.
Agreed.
Yeah.
Agreed. So since there's no branching logic, stuff like that, there's no functions. It's literally just raw instruction by instruction. So we'll start with like maybe let's call it like just like a phantom root node. We'll just call it like root, and let's keep it like LVMIR type, where the names of like registers and things start with a percent.
Yeah.
And it's also going to be SSA. So we're going to do single static assignment, which means that once we declare once we assign a value to a variable or register like this, you can't reassign. It's set. That makes it way simpler to do analyses and stuff.
Yeah.
So we'll start with like a root node, and the location of this will be something like 000.
Now, is this something the user needs to
No,
specify always?
they don't need to specify it. It's just there in the background, like no comment for it or anything. We just assume it's there.
Yeah.
And the reason we would do it is that like the way I imagine something like the AND gate being represented is, I mean, obviously we need to start with our input nodes. So maybe we could do something like if we imagine that the root block is something that like you're looking at and you're looking at it and you're facing north, right? Then we could say that on the root block, towards east and west, we have blocks that connect to it.
Is that our calling convention, Tammy?
Our calling convention is we put the first argument to east. uh, we'll see. I don't think we're at the level of needing to maintain ABI compatibility, so luckily we can define that later. But
yeah, let's assume that we put one to our left and one to our right.
Right. So we could do something like equals lever, and then how do we specify attachment? We can do something maybe like root east, like so, for attachment. Or we could even treat them as like arguments, quote unquote, like so.
Now, if we are doing north, south, east, west,
Right.
those are absolutes, meaning that like if we decided in our exporter
To change the orientation.
Yeah.
We can provide offsets. We can make that an option and we would just flip everything. Right. So like you always design the RCL circuit like saying like assuming north.
Okay.
Like just relative, but then you can always flip that in
sounds good.
in generation, right?
Yeah.
So yeah, we're basically invariant to orientation. And so you could do something like input 1 and input 2 equals lever root west, like so, right? So now you have two inputs. Now here's the other question though, because what we just did is we just said there's two levers. What this would effectively do right now, I guess if we took it literally to what we just discussed, there would be like the root block, if you can imagine it, and then there's just two levers on the block. Yeah. So that's not good. So I guess the actual way we would define this would be like input 1 block would be just like block that connects, and then input 2 block would also be a block that connects, and then actual input 1 would be a lever on top of input 1 block facing like south, because like you're looking at the root block north, like you're facing north. So if it's on the south side of that block, then the lever's in front of you.
Yeah.
Right. And then same thing here. Input 2 block. Does that kind of make sense?
I think so.
And so I think that makes sense. So like this would basically just look like two blocks with levers on them, and you're facing them because you're facing north, and the levers are placed on the south sides of the blocks. So.
Right. What happens if you want to place on the top of the block?
So I was thinking, apart from north, south, east, and west, we would also have up and down.
Okay.
So if you wanted to place on top, like a torch on top or something, you would do up and down.
That works.
Well, you can never place anything on the underside of the block.
Right.
So then we'll just do top.
Okay.
And there's no need for bottom. So, okay, that works. All right.
Well, in the case that like we wanted to place something underneath a block, let's say we had a block that we know the position, like we have referenced that block,
right,
and we want to place redstone on the block underneath it, we would then need to first know the block underneath the redstone or to do it.
Yeah. Which makes sense.
That makes sense. Yeah.
Good. Perfect. So now that we've got two levers, we want to connect them to two other blocks that have redstone torches on them.
Yeah, but those are the same block, same two blocks. If you look at the image, like.
Oh, okay. I was imagining like the actual AND gate would be slightly separated, but like yeah, you could do it that way too. which yeah, this is a better, okay, what you said is a better example of RCL, I guess. So like we do something like, well, okay, the thing is, we could even support like unnamed assignments. So for example, like the torch that connects to input one block on the top, right? We don't need to assign this to anything because we would never use it anyway. This is basic because like we would never connect again to the torch, right? Like we're never putting anything relative to them. So should RCL support like unnamed assignments like this sort of thing, or like this, or should we make it so that you always have to provide like a name even if you're not using it? I feel like for errors it'll probably be easier if we always
That
force
is
a name.
true.
Because then if you like try and duplicate placement, then we
Right.
can.
And I mean, like we're getting a little bit into an implementation detail that we might want to mess around with.
Right.
Like let's start with forcing a name, like forcing a variable.
Let's start with forcing a name. Also, I see a question I saw a question from Shiva. Thanks for joining. The question something along the lines of like, are we planning on creating ALUs and stuff like that? I mean, eventually, yes, we do plan on getting there. Like we do plan on getting to doing like actual arithmetic and logic and building out like more complex circuitry. Right now, though, we are quite literally just defining a circuit. So like there's no, high level if statements or loops or variables or anything. It's quite literally just here's a block, here's a lever, here's a redstone dust that connects these things. And then we will build logical abstractions of these like AND gates, OR gates, and so on, and then build further abstractions of those into the ideas of memory and instructions. And that's where the ALU type things would come in. So we're getting there soon. But for now, we have to start with the basics. So yeah, let's force a name. Let's say even just like placeholder names like A and B, right? So we can place torches like so, and then we would place redstone dust on top of the root block.
If you go back to the picture that we were referring to, where is this?
I was imagining like this middle block here,
the
the root block.
Yeah, that makes sense.
Yeah. So by default, we'll make it so that root exists as like a phantom position, but isn't actually a material block in case you don't want a block there.
Yeah, that
right?
makes sense.
In order to place a block at the root block, maybe we'll have like special syntax that says something like root block. Or like you can call this whatever you want. Like the variable name doesn't matter. But the special syntax would be block root. This will be the only time that the block instruction will be allowed without a direction.
Or we make it always allowed and we allow users to override their previous code and it's a mess.
Oh, clearly you're a C++ compiler developer.
No, this is good. That's a good idea. Special case. Yeah, please.
Dear God. Yeah, we're not doing overloading.
What this means from implementation standpoint is that as soon as like the requirement is met that we have one variable that is calling root without a direction attribute, that's like a met requirement and you're never allowed to do that again.
Right, pretty much. Because what this would say is basically, yeah, I want to assign a block at the root position. Because it's at the root position, it's the only one we already know the position of, so we don't need a directional modifier. But the logic would be that if there wouldn't necessarily be special logic that prevents you from assigning to root again. It would be the same logic that determines if you're reassigning to any position.
Yeah.
So
would in general not be allowed.
Right, exactly. So that helps us because then we can do like dust on top of root block on top, and then we can do we would need to put a torch on the north side of the root block. So we would say something like and output equals or actually no, this would also just be a random.
Yeah, because you need to invert the
torch. Yeah. No, but this is the inverting torch.
Yeah, but it's still the torch, not the final.
Yeah, fair. Torch on the root block north.
Sounds right.
And then finally, the actual output would be a redstone lamp that we put on the end. which would just be like output block equals lamp attached to. Yeah, I mean, I guess we could do that because the torch technically takes up a block space. So if it's attached to the north of the torch, then that works. So, yeah, I guess this would actually be the and output then. And then so lamp on and output north. Put like a lamp right in front of the torch right there.
Yeah, but like the torch. Hold on. No, never mind. I was mistaken. Yeah, that works. Right. All good.
So this is our end game. There we go.
Yeah.
That's our CL. Actually, this shouldn't be too hard to parse.
No, that looks pretty straightforward.
Yeah, like I don't want to regret saying that in the future, and it ends up being a really complicated parser. But I have a feeling it's probably going to be relatively simple to parse.
Now the question is, what does the internal
Representation look like?
the program state?
So for context, we're coding this in Rust, and so the way I imagine we could represent it internally. And I guess whoever ends up implementing this decides the actual details because you only find this stuff out in implementation. But is in general, since everything follows the same pattern of you are always assigning to a register, and you have, now that I think about it, only ever, oh, wait. I was gonna say you only have like two parameters. You only have like what to attach to and where to attach to it.
Yeah.
But I'm realizing that you might also have additional parameters sometimes. Like if you have like a redstone repeater, then you'll have like what the delay is on ticks.
Yes.
Right. And comparators have like the
But
thing you
what
can
if
click
those
on and off.
are what if those are attributes like in
That's what I was thinking. Like in angular brackets.
Yes,
Yeah.
exactly.
That's exactly what I was thinking too. So we'll make it so that for example, if I wanted like let's make a simple clock, right? So we'll make a simple redstone clock. I feel like I should probably just also launch Minecraft for this. That'll make things easier. But basically, we will make it so that if you wanted like a repeater with a delay, you could do something like. Okay, well, let's not allow special tokens to be variable names.
Yes.
So repeater, and then like the delay in ticks would go here. So like let's just say that you wanted like a 3-tick delay.
Yeah.
Right. And then you would attach it to like root node, root block. And like imagine you wanted like the root block and you just wanted to place it. Actually, you would never theoretically be able to place a redstone repeater anywhere but the top of a block. Does that make sense?
Yes.
So you would have to do something like rep1 base, right? Kind of like we made the block for the lever. It's like rep1 block would be like a block on top of the root block, or even just actually, yeah, even if we had a root block, you could do something like repeater1 equals repeater 3-tick delay on top of root block top, like that. But you couldn't really say like east or anything because then it doesn't exist on anything.
Right.
Right.
So we want that to be. Yeah, no, that makes sense. That it's gonna be a lot easier to validate if we follow those rules now. Yeah.
Because like there's the theoretical case where someone could say, oh, there's like a block under the east side
but then you
of
have
the
to
thing.
validate
But
that later.
yeah, because you have to create like the internal world model and verify that it exists on something.
This is fine. It's it's an internal representation. It should be strict code.
Yeah, agreed. And if we want to change it later, we can, but it's easier to start with it not being that way.
Yeah.
So like if we were to define like a simple clock, for example, in Minecraft, so like imagining repeater and redstone and a torch. So if it was like just that, and we put up the delay a little bit and like so.
The most impressive thing about this is you just did all that with a trackpad.
What can I say? I'm just so used to doing this with a trackpad. uh, does it surprise you the fidelity of movement that I have with a
Yeah,
trackpad?
it was impressively quick.
I don't know. I'm used to it. There we go. Now it's delayed. So, what are the levels of delay you can have with a repeater again? So
There's four, right?
there's
Zero, one, two.
1, 2, 3, 4. Yeah, 4. And by default, it's a 1 tick delay, right? So,
Yes, there is always a delay. There's no zero
right.
tick
Yeah,
with the
yeah, yeah.
repeater.
Got it. Okay. That makes sense. I'm gonna do that. So this circuit exactly would be represented as um,
Now, do we want to always assume that there's a ground floor?
that's what I was thinking.
That's like a tough. Hmm. It is. It is.
Do we make it so that all of your ground needs to be like explicitly defined as blocks?
I want to say yes.
I also want to say yes.
It's RCL is not going to be easy code to write already,
Yeah.
so might as well give us extra guarantees.
Yeah.
You know,
Agreed.
otherwise we'll just have problems later.
Agreed. Then we're just gonna have like difficulty writing the actual language. Hey, I see. Shashank is asking which programming language is being used here. We're making our own. So the one that you're seeing here is a programming language that we are making as we speak.
Doesn't exist yet.
It doesn't
We are
exist yet.
defining the syntax for the first time right
That
now.
is
That's
correct.
what we're trying to figure out.
That is correct. And so we're still figuring it out ourselves. But we're gonna code the actual implementation of the parser and things like that in Rust.
Yeah. There might be some Python code for the
Might need to be for the world
interfacing with
generation.
Minecraft world gen. Yeah.
Yeah. Okay. So I think I'm pretty clear on what this language looks like.
I agree. Yeah.
Yeah. So the only ones that have like arguments to them would be the repeaters and the comparators. So the repeaters are the number of ticks for delay. The comparators are whether or not they're like activate. I always forget how comparator logic works.
Yeah. I can't say I know off the top of my head.
So yeah, we'll figure it out. But it's like
There's
whether
two
it's on or
states, right?
off.
Yeah,
Yeah,
there's two
basically.
states.
Yeah.
That's easy.
We'll just call it on off for now, then we can adjust. As far as I know, you can make a clock with these things too,
Yeah.
right? So like, or is it the other way? Like, do you turn it off and then? Huh. I forget how these are supposed to function. Or was I supposed to do this? I don't know. Anyway, we'll figure it out. Okay, so we should be able to start. So I guess now we decide who works on which piece.
Right, so I think what we had discussed before with me getting started on the parser and you get started on the exporter. I think that's a good start.
Okay, so yeah, I guess the goal for today then is we would like to get started on these two pieces. Well, not the simulate piece, just like this and this, right?
Yeah.
Okay, so let's see if we can do it.
Did you already explain why there's a simulate box?
I think so, but yeah, just like on a high level, it's pretty much because we want to make it so that every time we build circuits, we don't need to go through the entirety of Minecraft to test it.
Yeah.
We can just test it internally and verify that it exists in a state that we want it to make sure that circuit logic works well.
Yeah.
So, all right, let's begin. So you can get started on parsing.
Yeah.
You know what the syntax looks like. I'm gonna get started on exporting.
Hold on, where did you put the that file? Oh, it's not saved.
It's not saved yet. There it is. Yep.
Okay. And how should we structure this our directory?
Let's do a cargo new for RCL.
Yeah.
And then pretty much just in here we'll put all of our RCL code. You can write the first lines of code. And I'm first gonna get started on figuring out how to do Python world, like sorry, not Python, Minecraft world gen. I'll probably just do that in like a different temporary directory, and once I figure out the logic, we'll port it into RCL.
Okay, and for the internal representation, like it's literally just like a list.
Yeah, pretty
Yeah.
much. Literally just like a list of instructions.
Yeah.
Yeah, and then each instruction is like almost tree-like, but it's not really. It's just like an enum case.
It's like there's not enough going on here for me to
Yeah.
imagine like a tree.
Yeah, no, absolutely. But like, yeah, I envision everything like a tree. But it's pretty much just enum where like the different cases are like repeater, dust, whatever, and then the different arguments that would be passed in.
Yes.
And so technically the location would be like an optional one. But we would just always verify that it exists for everything except for the one that
Right.
connects to root.
Yeah.
Right. Or we make it so that for the sake of code simplicity, it's never optional, always has to be there, but there's like a special locational modifier called like none or something like that. That is only applicable if you are defining the root block position.
Okay, as I start implementing, we'll see what feels right.
Sure,
Yeah.
sure. Right.
Yeah, that might.
Because otherwise we have to do an if optional check everywhere.
Yeah,
Yeah.
that's true. That is true.
Because safety.
Yeah.
All right, let's figure this out. So let's get started with world gen.
Yeah.
So for context, everybody, I already have been taking a look into like different ways we could export or like write into a Minecraft world, and there seems to be quite a few different Python packages, but I mean, I sort of saw this coming. Not many Rust packages to do this. So we're gonna try and see if we can do it from Rust, and if not, then we're gonna use probably something like PyAnvil editor to modify the world. Let's see. So I guess the first thing let's do is see Rust Minecraft world editor. I guess there's not going to be much online because Rust is also the name of the game. So I guess Minecraft world editor language Rust. Let's see. Oh, I gotta sign in the search code. Incredible. Okay. I gotta do two-factor auth. One moment. There. Okay.
And on my end, I may be a bit quiet for a little while as I'm just trying to figure out the specific how to use this Rust parser library that we'll be using to actually create the parser for RCL. The name of the library I'm going to be using is test parser. Seems like a pretty straightforward and nice library for creating non-ambiguous grammars. So yeah,
Wonderful.
but I will update you guys once I have something.
Sounds good. In the meanwhile, let's take a look at exports. Okay, so there seems to be a Rust parser for Minecraft's Anvil world format. Do they let us modify it or just parse it? Let's see.
Are there any things that an RCL file needs to contain?
Needs to contain. I don't think so. Like if you were to give us just an empty RCL file, we wouldn't do anything. And then
And our higher level RLL compiles could like you couldn't you compile to a single RCL file.
yeah.
Is our final code usually compiled to a single RCL file? Is that the intention?
Yeah, I would imagine so. I don't want to build a linker.
Yeah. Very fair, very fair. Yeah, so then in that case there's no real requirements that like I was thinking about like stuff like necessary IO, stuff like that, but none of that matters if everything's encapsulated in that one file.
Exactly.
That one file is the Minecraft world, kind of.
Exactly.
Yeah, that's good. Simple.
So
Also, sorry, my chair.
I don't think the noise comes in through the stream because we have noise
good.
cancellation.
That's good. That's good. Hope so.
Okay. Oh, there's a project that was updated 9 days ago. Still a work in progress, apparently. Hey, it looks like this guy is actually building. Wait, is he talking to Python too? Oh, wait, that's actually really funny. This guy seems to be building a project that is actually really similar to what we might want to do. He has a Python binding, and he is using it to parse the Minecraft files.
You know what I don't see?
What?
A license file.
Well, you see, this is also a Rust project, so maybe the license. Okay, no, there's no license in here either. Okay.
Is this actually like actively developed?
2 months ago, there was a README. 9 days ago was the latest commit. So
14 commits those. They're spread out. Maybe it is kind of active.
Yeah, maybe it is kind of active. Anyway, if whoever's building this is seeing this and wants to help out with our version.
I like the readme.
All right, well, we're gonna build our own, I guess, using Python because it needs to be further along than where this is right now. And it's also mainly for editing than it is for reading. What we want to do, at least. Let's start with looking at PyAnvil editor. So let's get a little MVP of PyAnvil editor running locally, I guess. Do I have Python installed here? Yeah, I do. Okay. So let's install package. Let's run a simple script. Okay, and I also probably want like this basics for my Vim. Okay. So load the world folder. Let's load up. Let's see where this Minecraft world folder is. And let's just point it to that. So open world folder. There it is. I'm gonna rename this to Redstone or RCL test. Great. Did that rename the folder too, or does it just? No, it doesn't. Okay, whatever. I'm gonna copy this out to here. RCL test, and let's load that in. Okay. So I need to find the location of something interesting in this world to read. How about some of the circuits we've built already? So let's just put down sandstone. Let's put down sandstone with redstone dust on it, sandstone with a redstone repeater on it, and then sandstone with a redstone torch on it. The location for this block is... Well, I guess the question is whether the XYZ coordinates in Minecraft are like the block you're standing on, or the
It's block you're standing on.
in or on.
Good point. I think it's on, but
I'm
not even sure.
No, it's the one you're standing in. Because the targeted block right now is 56.
That's true.
Right. That's true. So -4, 56, 29 is the tuple of like that
your bottom standing block.
Right. Yeah.
Okay.
So I would need to make this the position.
And are we going XYZ or are we switching to XZY for when we
Let's go XYZ, because XZY was something I only brought up because we'd be writing.
That's true. That's true.
Yeah. So let's get the block, and let's just print out the block for now. Also, I need to what's the Vim setting for auto indent? Yeah. I always come back to this one Stack Exchange answer to grab the little snippet for my vimrc like that. There we are. Great. Okay. So right now, if I were to run this script, it should just print like error. Okay, that's interesting. Why does it not see it? Do I need to pip install from like here directly?
As soon as this parser is done, I am making a formatter that turns all the blocks to diamond blocks.
Okay. You know, it always confuses me when packages, when you install them through pip and it complains about another pip package not existing. Like, why could you not have specified that as a dependency? Because it would then install. But anyway. Okay, it also needs Python. Does this need Python? It doesn't seem to me like it does. I think we're installing a different package. I'm just gonna clone this and install it myself. Let's see. It was surprisingly slow there.
Should we make it that our CL should have at least one line, at least one something, or like, will the parser be a-okay with an empty file, and then we just deal with that later?
Okay, we'll answer this question by doing
It's really just a question of, is it a parser error or is it
test.c. Clang
very true?
test.c
Very true.
as.
Let's find out.
Okay, well, Clang's not running. What the hell? Oh my god. My environment is somewhat messed up. I need to just delete the dynamic linker stuff. Clang accepts it, so we'll accept it.
Simple as that.
It's a very interesting test, actually. Okay, so apparently this editor doesn't even exist as a Python package, so I just need to like manually move it here. Does this have like an init.py? It does. So I would also want to make one here and then do from .pyanvil import world. Does that work? Let's see. No known parent package. Okay, I can never figure out when it needs me to use a dot and when it doesn't, so we're just gonna not do that. And that import was wrong. Okay, level doesn't exist. Okay, so that's an internal error within PyAnvil editor. I have a feeling that this might not work because maybe it's just not up to date or something. Unless it expects like a different world folder, but like this is all the stuff in the world, so I highly doubt it. Maybe it needs the region folder. Yeah, I don't believe so. Also, the latest commit was like 3 years ago. So yeah, let's find a different one. This is probably just too old. Let's see if the amulet editor works. Amulet core. This one's way more active, updated 4 hours ago most recently. Okay. Since there were commits 2 years ago, I'm curious to see if GPT knows about this. Do you know about the amulet editor? About the amulet Minecraft editor package. Python. This is another really interesting thing about this stream is that I guess folks get to see just how much GPT can be used in development.
Yeah.
It's interesting because you never really think that you would use it that much, but there's just so much repetitive code and just stuff that we may not know the random API calls for and things like that that this helps with. Let's see. Okay, apparently it needs a bunch of dependencies. WX Python, IMC translate. Okay, now it looks to be actually installing it. So while that goes through, we're also going to need to generate bindings into Python so that our Rust code can call the Python package. So we're going to use Rust Python for that. Or actually, yeah, that's a really good point. There's a Rust Python interpreter. Instead of binding into C Python, we can just use Rust Python to directly execute the code.
Yeah.
Okay, wonderful. That makes things simpler actually, because the C bindings are annoying. And this will be my first time properly using Rust Python as well, so that'll be nice. Amazing. Okay, so we're done installing Amulet. Let's see if GPT can write a simple example. Can you write a simple script that uses Amulet to determine the type of block at position? What was the position that I specified? -4, 56, and 29. Okay. Looks simple enough. Let's try it out. Okay, well, actually, I just realized this doesn't exist, so I gotta first provide a path, which is RCL test. RCL test. Okay, so let's just also put some prints. Loaded world. And let's see if this works. Okay, no module named amulet API world. Let's see if it just completely came up with that. Let's also look at the documentation. This website is not formatted very nicely. It's very hard to find where like the documentation is. There has to be an actual docs page for this. Okay, well, right there. Never mind. Core API reference, Amulet API world. Okay, so I think I need to install Amulet API core. Amulet. That seems like it's already there. Amulet API. Okay, so world just doesn't exist. Okay, so load level probably does what I needed to do. So let's do from amulet import load world or load level. And then instead of world, this would be. Let's try that. Okay, closer. Okay, so it did load the world. Okay, so we're getting there. Now that we've got the world, we need to specify version. Let's see, world.get version block. Strike structure, get block. Okay, let's just try get block instead of get version block. Does that just do it for us? XYZ dimension. And there we go, it's air. That's correct because we didn't swap out the world files. But now if I were to take this and if I were to save the world, and if I were to go up to Minecraft again, go to saves, copy this back into here, and I call this RCL test 2, and if I modify this to look at RCL test 2 and then rerun it, then there we go. We get sandstone. Nice. We can read. Now that we can read, let's see if we can also read the other blocks that we saw. So, wait, no, not multiplayer, single player again, because I want to see if we can like look at the orientation of things like redstone and stuff. So, if we're over here, then the block that we're targeting here is 456.29. This is 450 or 5 -556. The thing on top of it is 57, obviously. Great. So if I read if I were to read -556 29. Wait, let's just print it. Yeah.
September. Have you heard how people describe the null keyword as like the $1 billion mistake? Hear me out. My solution is the root block because we don't have a direction for it, but I don't like null, so we're gonna use NA. Except it has to be uppercase, and it has to include the slash in between it. We do not have division in this language. It's all fine.
It's just treated as its own special keyword.
Yeah.
It's
No.
the only context in which a slash should occur.
I can't do that. I can't do that. We're going to stick with null just because it's understandable.
Yeah.
Yeah.
Oh, that's funny. All right, I'm looking at the live chat as well. Here I see Rohit says thanks for the session. Of course, thank you for joining us. I think this is a really fun project. So once again, any suggestions you have, any questions, anything you want to see us do, feel free to let us know. I also see the coder Tharva's joined. Thank you for joining. Okay, so it looks like we can read blocks. So we see sandstone, we see redstone wire. How about now we attempt to read the torch? So 6 and 7, those should be the other blocks that I placed. Yeah, so we got repeater, redstone torch. Okay, that's what we need to modify there. So facing equals north. Okay, that's perfect because we have like north, south, east, west. We have those directions. That is the exact NBT. I think this is NBT data, if I understand correctly. So this NBT data, we can modify based off of like our directions, and we should be good. And then for things like, right, the only thing that is now confusing is things like how redstone torches are attached to things. Because we could have a torch that is like this or like this. Those are two different ways of placing it, but they occupy the same like theoretical block position, right? So if I were to place something down here, the targeted block is -75630, but here same thing, -75630. So we have to see what the difference is in the way that these two are represented in Minecraft. So that would mean that I'm looking at 5630 and okay. So gonna save it. Let's take a look at 30. So those should be on the ground and attached to block. Like so. And I'm also just going to delete the two world files because now we can just use one. And there we are. So let's read from the file. Okay. So it's the way that they are facing that determines how they're attached. That means that actually works perfectly from an RCL perspective as well, now that I think about it, because if someone says that the redstone torch is on top of something, then we just do facing equals up and put it on that position. But if it's attached to the side of a block, then it would still be the same coordinate offset, which is fine, but would have a facing parameter. We just need to look at what the orientation of that is. So like let's see. Like right now I am looking in the, let's see, where's the direction? Facing south right now. So if I were to, oh, okay, that also works perfectly from an RCL standpoint. So yeah, because if, like, imagine that sandstone's the root block. If I wanted a redstone, like imagine like I'm quote unquote, okay, now I'm genuinely facing north, right? So if I wanted to put a torch on the north side of the block, I would put that in RCL that way. And if I put that this way as well, this is what would happen in Minecraft, saying that it's like at that position facing north.
Yeah.
Right. At this position facing up would be like that. So we need to define a block.
Yeah.
So like, yeah, RCL is actually, I didn't know that Minecraft did it this way, but it actually works well.
Yeah.
Okay, very nice. We accidentally created something that actually works really well according to the underlying data. Okay. And then repeaters have similar facing logic. So we should be good to go on that end. Okay, facing north. I mean, I guess it's the opposite for repeaters then, because like, I guess this is the way that they're facing, but it's whatever, we just need to flip it. Should be good. So then theoretically, if I were to do this, it should say that it's facing east, as far as I understand it. So let's find out if that is in fact the case. So it should say facing east for the repeater. Yep, it does. Okay, we're good. We understand the basics of how we're supposed to read these files. Now we have something like another hour left for how long we've scheduled the stream for, although theoretically we can go for as long as we need to. Let's see if we can get some basics in for like actually writing Parser. So how far are you with parsing so far?
Working on the grammar definition. My mind does not work as fast as yours, Tanya. But yeah, I'm getting there. I'm using ChatGPT quite a bit with this. Because like I have
That actually makes complete sense.
Yeah, like it's a simple grammar, but like
Right.
the library defines a syntax for defining grammar.
I have a feeling GPT-4 would be infinitely better at this than GPT-5.
Probably.
Let me try it.
This has seemed pretty accurate so far.
Yeah.
And like I know what to fix if I need to fix it. But yeah, go ahead and give it a shot. Do you want the prompt I use?
Yeah, sure, why not? Let's see. Let me pull that up. I'm gonna see what you sent me.
Oh, oops. One sec.
No worries. Okay. So you said, wonderful. Okay. I'm gonna copy that. Let's throw that into here.
I mean, I have a prompt before that, where
yeah,
whatever.
So the way I would put it is like this. Can you please write a grammar for the Rust test crate to parse my custom language? This is an example of what the language looks like. Where?
Now, are we supporting UTF-32 or you okay with ASCII?
That's a good question, actually.
Hold on, let me check if PES even has support for anything above ASCII.
It should. I feel like the majority of like Rust crates support these sorts of things.
But do we really want to?
That is a good point. I feel like it would be nice to have if we were able to support
at
it.
the RCL level.
Fair. You know what? We will strip identifiers in higher levels if we support Unicode in them. Yeah, let's just assume ASCII for now.
Please.
Okay.
I asked as a joke, and then you serious thinking, which is always scary.
Okay, GPT-4. Yeah, also seems to be doing a pretty good job at it. Okay, I think it pretty much just did it.
What does it show for identifier? I'm not confident in the identifier answer I got.
It actually doesn't have an identifier.
Oh, that's interesting.
This is the way it does it.
Just send me that. I'll read it over and
Yeah, sure.
See. Yeah.
How about... Okay, I'm also gonna add to this the Redstone repeater example with the arts. Yeah.
That. Yes.
So like simple repeater.rcl. So then it would just be something like root block and then like repeater rep1 is equal to repeater 3 on top of root block, like so. The name, okay, yeah, like that. Okay.
Yeah, I forgot that too.
There. And then also may have an argument only in well, the repeater has an argument taken in angular brackets, either 1, 2, 3, 4, and the comparator also has an argument taken in angular brackets, either on or off. There we go. Okay, let's try that out. I think it should get it.
Comment is semicolon followed by not a new line, followed by anything, followed by new line. Yeah. Variable atomic, not an equal sign, followed by any, but more than one thing. Variable, we probably want variable made up of identifier, and then identifier is alphanumeric. Or either that, or I just put the alphanumeric thing directly into variable.
Does it need to?
Well, unless like for some reason wants to support more than, like most variables are
fair.
With the,
Fair.
starts with the
okay,
letter.
yeah, I'm gonna send this to you and you take it from here. There we go. And yes, as you noted, Shiva, how to use ChatGPT as a developer.
Yeah.
Yeah, that pretty much is that is a genuine skill at this point.
Step 1 is don't write proprietary code. That's the one case where you can't use ChatGPT effectively because
Unfortunate.
It's allowed.
Yeah, but that's always a thing. Is even just knowing how to prompt these things is a skill. Okay. I'm gonna define. Let's see. I'm gonna create a new project. We'll call it RCL export test. We're gonna delete this eventually. This is just so that I have a place to write Rust code. So within here, let's imagine that I have an enum called RCL instruction, and RCL instruction consists of block.
Oh, your swap files do not get shared. Do not get they get like a special location.
Oh yeah, it's because I use NeoVim on that machine. My apologies.
There's no delete.
You just have to copy the path and RM it. I hate it a lot.
Yeah.
I honestly do not know why NeoVim does it that way. There has to be a setting for it. I'll get to that eventually. Okay.
You could theoretically spend all your time configuring your dev environment and no time actually developing.
I know a few people that do that a lot. That's why I use Vim, so I don't need to set things up. Okay, so we have blocks. What do blocks? Blocks will just consist of, I mean, any instruction would have the locations. So let's not specify that at the instruction level. Block exists, dust exists, torch exists, repeater, comparator lever and lamp. So, except the repeater has the delay, right? And the comparator has enabled, which actually, what's the actual term for it?
Now this grammar is not too strict about the repeater and comparator argument thing, which is like, it's fine. We can do some semantic analysis if we wanted to. But I'm wondering if there is a way to make this more strict. But then the parser needs to do extra work.
Well, it shouldn't be too hard, because you would just say that it's either equals and then either like primitive or arg primitive and this.
Better idea.
What?
But actually, I was not really listening to what you said. But inside the primitive, underneath, beside repeater.
Oh yeah, you just put arg beside it. Nice. Okay. Yeah. So it's like it's like the primitive would be repeater plus arg.
Yes.
Okay. Great. Yeah.
I like that.
I don't know if that's exactly amenable to the best error messages, but still, it doesn't matter. For now, let's just get a parser in.
Okay.
Yeah. I remember a long time ago, this is something that I did like way before I even started like really doing stuff too actively on YouTube. I built a little like interpreted programming language. It was super simple, super bare bones, and it was in Swift. But I remember that the single worst part of it by far was the front end. The actual parsing of tokens was really, really painful. So
yeah, I mean, if you look at parser code of like real compilers out there, it is even at that level, it's complete spaghetti code. Everyone's just trying their best.
Okay. So we don't just need the instructions, we also need a struct to hold like a material instruction. So we would have like an instruction kind, and then an RTL instruction, I imagine, where we would have like the instruction and the relative to some other block identifier. And so that would be a string.
Yeah, I'm gonna change the variable.
Yeah.
Just use more traditional grammar.
Fair. So relative to some sort of string, and then x, well, not x, facing, and then we would have like an enum for direction, and then top, call it null. I'm thinking of a better word for this. There's north, south, northeast, southwest, top. Could we do like inside instead of null? It's whatever. Let's just do null.
Yeah, it's gonna be a bit ugly because we don't have a bottom, and we will have a null. It's just
it's whatever. Doesn't matter.
It's okay.
Yeah.
Like if you ever need an excuse, this is not user-friendly code. This is IR.
Exactly. Okay, there we go. GitHub Copilot is so useful for that sort of thing. Just built the whole constructor thing for me. So we're gonna say relative to root here. And then actually, do you think you could parse into this here? The code that I just like basically defined?
Yeah.
Yeah, perfect.
Yeah, that's I mean more or less what I was like going to be parsing into.
So I'm gonna just like throw this into your code so that you can also use the same definitions, and then we'll merge. So yeah, as long as you can parse into this, I can take it from there. So let's just imagine I manually turned the code that we wrote for the AND gate. Where did I put that? Oh yeah, it's over here. All right, let's watch Copilot's magic. We're gonna just put a comment with the RCL that I wrote. Right. So, and then we are going to simply, oh, but they all individually need to have names as well. That's a good point.
Okay, beautiful. I think this is the final picture.
Nice.
Now let's see how this actually turns into Rust code. Some really useful examples for this library.
Nice. There we go. Copilot turns all those RCL instructions into the Rust enum. Incredible. That was so convenient. Okay, this looks like it is right to me. So now the challenge is if I can take these instructions and actually turn them into a genuine Minecraft world, which is a fun challenge. I guess the first thing that needs to happen is we need to materialize genuine coordinates for all these things, right? And also do validation of the logic. Not really the logic, more the data to verify that we're not like trying to put things on coordinates that already exist. Sort of thing. So let's make sure that this compiles as it is already. No.
Do you understand this? I haven't used crates in a while.
Let's see. The error you're getting is failed to load source for dependency. I can probably recreate that myself.
No, I'm just trying to add a pest.
Oh, okay. Well, I usually just modify the cargo toml directly.
Yeah.
Pest equals. Okay, we're gonna do something really bad here.
2.7.
2.7. Okay, I was just gonna do this, but let's just do that. So it should build. Oh no, pest doesn't exist. What?
Yeah, that's what I got. Yeah.
Oh, let's see. What's the package version? What's the cargo? Pest.
Yeah, I looked.
Oh my
up
god.
and tried the same thing. Yeah. Like the Rust pest.
Oh, it's 1.0.6.
That is not at all what mine just says.
Wait, yeah, yours says two. What? Okay, for some reason Google just had an older version cached for their result. Isn't that wonderful? Wait, why can Rust just not see that package? What? Oh, it's because of my git config, I think.
Interesting.
Because I set it to, hold on. Okay, you know what? Watch this. This is gonna be fun. How do I? Okay, what environment variable will make Git stop using my custom authentication? Okay, so maybe I don't think this will actually do it because it's probably a git config thing, but okay, yeah, no, it's why is the file not? Oh no, it is. Okay, so I'm gonna quickly check. Yeah, we just need to remove this, and then there we go.
Beautiful.
Yeah, it's pausing it. Yep, no worries. All right, yep, it does in fact build. Almost. Do you have the main file open right now?
I do.
Just remove the delay and subtracting. They can't be named. You just have to put the types. I forgot that that was a syntax thing.
Do you know any other languages that have this like thing where you add a data type to enum values?
Sorry? A language? What languages let you put data types in enums?
Yeah, besides Rust.
Swift.
Okay, I kind of figured based on what you wrote there that you had accidentally written Swift code.
Yes, no, that was actually it. Yeah, for context, everybody, like this is enabling you to put like the values of these types inside the actual enum cases. And in Swift, you can actually put multiple values and they can be named. But in Rust, they're not named in the enum because it doesn't make sense for the rest of the Rust syntax. So they don't let you put names, and I forgot that. But also, yep, I see UA says on YouTube, never expected this to be how I spend my Sunday. Honestly, I can't think of a better way to spend a Sunday. But also, Shiva, I see you register for tomorrow's AMA for Isaka. Thank you. And yes, of course, glad to answer any questions anyone may have on tomorrow's AMA that I have with Isaka. More details will be on my social media soon. But feel free to go ahead and register for that, and looking forward to interacting with everybody. And yeah, let's get started with actual instruction generation. So what we have to do is we have to materialize basically a list of blocks that we would like to place in Minecraft, which means that we have to do like our own kind of world gen almost, um, for lack of a better way of putting it, I guess.
Why am I gonna?
That's a good question. So let's go ahead and modularize a bit more so it's easier to reason about this code. Let's go ahead and vim RCL. Let's instruction.rs is probably a good name for it. And then let's throw this stuff into here. So this is like the raw instruction definitions and stuff, right? And then let's also do export.rs. This is where we're going to put all our export logic. I do think, whoops, okay, did not mean to write that to a file named colon. I think I need to do mod instruction and mod export. And then from here I need to do use create instruction. And then I need to say RCL instruction, RCL instruction kind, like so. So we're going to start by creating a structure that will store the actual world itself, and we'll call it RCL world gen, right? What we'll do is we'll implement this one instruction kind at a time, right? So we'll start with offsets. So we'll store root x. Maybe I should create a coordinate structure. I should do that. Let's create a coordinate structure, and it's going to have an x, y, and z, right?
You're not in the main file at all, right?
No, I'm in a different project because I don't want to overlap.
Yeah.
Once we have the coordinate, let's do root coord. Right.
Random question. Do you know any editors that have really good like real-time support for multiple people?
IntelliJ, like the JetBrains suite.
Yeah.
Does really good with that actually. Yeah.
I never used it on there. Yeah.
We've used it a few times. Actually, we used to I did a couple live streams with Omer. That funny enough, actually, one of the live streams we were doing is we were trying to build a compiler in Go to the Piet language. Do you know what Piet is?
That rings a bell.
It's the one. It's like the image programming language.
You showed me this. Yes.
Yeah. So we tried to build a little. We didn't finish it. Hopefully we finish this one. But basically, like it's a language that reads images, and we tried to compile code to it. It was fun. Okay, so we need the root coordinate. We also need to know we need to know where all the blocks are that we've placed so far. So we need to have blocks. So this is where we actually need to start materializing genuine Minecraft blocks. So we'll call it, we'll create a trait called Minecraft block, and anything that implements this trait will have a function that exports both the name of the block and the NBT data that needs to be associated with it and its position.
Your copilot or whatever is looking for me too, which I did not expect it.
Well, I mean, your SSH in my
Yeah,
computer.
I just pieced it together, yeah.
Nice.
Saves me some time.
Nice. So, well, I mean, actually, we wouldn't even need the trait because we could just create a structure called export it RCL block export, and this would contain the name. Yep, that's yeah. So it would contain the name, the coordinate. We'll call it name position, and then NBT, which would just be hash map, and we'll do a use of hash map there. Okay. Probably want to derive some traits on these things, but we'll get to that later. So basically, this will be the structure that, or this structure will like hold the raw exported block data for the purpose of generating the final Minecraft world. Okay. So the blocks would be a bunch of RCL block exports. So, and then we would also store coordinate the exports, the other blocks that we've seen so far, or the other positions at least. So, we would do known positions, or I guess even world would be a good thing for it, because we would go from coordinate to actually no, we would go from the name of an instruction to the coordinate at which we place, and we would use this for directional data.
Can I rename this?
What?
RCL instruction kind.
Yeah, sure.
Okay. I think like RCL primitive makes more sense.
Primitive, well, does it? That's, yeah, you're right. Instruction implies that there's like logic.
And that brings me to my second thing right here, RCL instruction. Even
Yeah.
that's not signal. I mean, I use placement in a grammar definition.
Ah,
Is that bad?
placement, RCL placement. Because
Technically,
maybe call it like a primitive kind, and then the actual primitive consists of, because okay, well actually no, you're right. Because
primitives
the
are
primitive, yeah.
types of data.
Right. So what do we call the actual instances? Because they're not instructions. I don't like the word placement also feels off to me though.
It's not a common word in code. Something silly like instantiation is way too
RCL
instant. Instance?
instant.
Is that
What's a component?
does that work?
I think so. It's a component of a circuit. The component consists of
I'm
the
okay with
primitive
it.
and then also additional information that
Okay.
allows it to materialize
We
into a
can
component.
move on.
All right, let's go with that.
Okay.
So yeah, I'll change mine too, I guess. RCL instruction kind is actually RCL primitive. So I'm gonna go ahead and do the same thing here. So yeah, this is our known world so far. So let's go ahead and implement RCL world. Um, so we want to derive like actually a couple. Okay, that makes sense. Yeah, Shiva mentioned that you thought this was just about lexical analysis and parsing. That is definitely a part of it. That's the part that Paul's working on right now, and so we're gonna like hopefully merge what we're working on soon.
Yeah.
But I'm currently working on the other part, which is, after we've parsed it, can we actually turn it into Minecraft world? So the idea is that in here, when the only thing we would start with is the actual like root coordinate. And then we would just figure out the rest as defaults. We can make this a public structure. We'll probably also need to make this a public structure. We'll need to make all these fields public, which means that this one also needs to be public. So, and I'll make the root coordinate public. Or actually, I don't think we even need to do that. Okay. So that's good. We'll also need the new function to be public, which then also brings up. We'll change those ones later. So let's make a simple function that's able to place or I wouldn't say parse, but I'm trying to think of a word for the world gen is going to have a function that like takes an instruction and updates the world gen state based off of it. We could even call it update. So the update would take a mutable reference to self because it would need to update its state. And it would also take the actual component. It would, I think we would take ownership of it. Makes sense because we needed strings. And then block name. Let's do that. And then returns nothing for now. So now that I think about it, block name can probably be a static string, like so, because what I would probably want to do is just purposely globally leak that memory because we're always going to need it. And it's like 4 strings. Or actually not even leak it, just like make a const string basically. So we would say like our block type. Yeah, like so would be equal to like, yeah, let's just make it stone for now. There we go. Dust type, torch type, repeater type, comparator type, lever type, and lamp type. There we or not. Okay, that's not. We don't want glowstone. Come on, Copilot. Don't you know Minecraft? All right, so we got a lamp. Got 20 more minutes left. Let's see if we can potentially do like simple world gen here. So when we update, we want to update our state. And the way we're going to do it is first we got to check what kind of component we're dealing with, right? So that would completely change our logic. So yeah, we'll make special functions. We'll make these ones private. So we'll say update block, right? That also takes mutable reference to self. This will probably just take the name of the instruction. Actually, no, we'll take the whole structure. But then the data inside the actual thing is not specialized. So the RCL component still contains an RCL primitive, so we need to do like a check, which is okay actually. So yeah, let's make update block here, and we'll just do a quick guard. So we'll say let RCL primitive block equals component dot instruction else attempted to update a block. Yeah, so that's a good safety check actually. And then once we do that safety check, we can do coordinate. Okay, yeah. So this is gonna try and this is where the error handling comes in, right? So what I'm thinking is we create another function, say get position, and it's going to be relative to some other thing, right? And this can be a reference, and also direction is something we would take into account. I will also want to include direction then, right? So if we want to get the position relative to something, we would do relative to coordinate, relative to components, relative to coordinate. So we're not going to force unwrap. Instead, we're going to attempt to unwrap. But if it doesn't work, then we're going to panic. And the way we're going to panic is we're going to say, actually, maybe it doesn't make sense to panic. Maybe instead we return a result of a coordinate, and the error will be, what kind of error should we give it? We're going to want something that implements the error type, and I'm forgetting the exact way we do it. Let's just throw in some GPT here. We don't need GPT-4 for that. That's overkill. Show me an example of implementing a custom error type in Rust. Okay, yeah, that's actually perfect, because then what we can do is we can say pub struct RCL world gen error. Yep, there we go. It'll have a message. Do we want anything else? Maybe the error should contain also like the node that we were trying to generate. So that way, well, we would have different error kinds. So the only errors I can possibly imagine we would have are syntax ones. And then there's also the kinds of errors where you tried to like place a block where it can't have gone.
Yeah.
And of those errors, it would be either you're placing something where something's already placed, or you're placing something that needs a base, but doesn't have a base. So let's deal with those two kinds of errors. So pub enum RCL world gen error kind. And it's like block already exists, block does not exist, right? So then we would do something like pub error type, pub component name, right? And if block already exists, then like what's the name of the component? Could we do that? So like the way we would detect that is we would try and right, because it's like how do we even detect that something exists at that position? The hash map that we have goes from the name of a component to its location, not the other way around. So we could potentially store a two-way mapping, but I don't want two sources of truth. So instead, we store a set, an additional set. Or is there a crate that implements a two-way hash map that's efficient? Bidirectional hash map Rust. Is there a crate that just does this for us? There is, amazing. Okay. I'm just gonna use this crate then, by map. Because we're gonna need a two-way mapping. Use by map. By map. Great, seems like it knows what that is. World is now a by map. Great. Get by left, create, it gets that. Copilot is awesome. So yeah, if a block already exists, we will say existing component name, or actually I forget you can't name these enum types, enum variables again. Block does not exist. Okay. I wonder if we were to error out, will we have consumed anything from the actual structure of the component? Because I'm wondering if we could take ownership of the component and throw it in here. Because I also want the kind. Or like the primitive. So we'll say like name primitive. Here's what we can do. Right, so we will put the actual component that caused the error inside the error type, and then in the update function, we can return a result of either nothing or RCL world gen error. And if one of these things throws an error itself, we'll guarantee that they're throwing RCL world gen error type, right, which is just the enum. But any high level functions like this one, when calling it, like so, can wrap it. So we would say something along the lines of match let position equals match self by position. So if this was okay, then it's the position. If it's an error, then we go ahead and materialize that larger error type, and it takes ownership of the component and it's able to leave. Otherwise, we can continue with what we were trying to do. So because of that, we now have fully comprehensive error information, which is great. Amazing. So if we are getting a position relative to something, so we want to get, relative to the root block, for example, so we can place a block there and then place a lever on it. At first, when we get that position, we want to make sure that the thing we're getting relative to actually exists. So this is somewhat syntax validation, but not really. So there's block already exists. So this error is while trying to place a component at a position, I'm going to put this comment on the previous line. We found that the position was already occupied. That one works. The next one is while trying to place a component at a position, we found that the position we were trying to place the component relative to, or the component that we were trying to define that while trying to place component A at a position, we found that component B, actually no, better way to describe this, component A relative to component B. We found that component B does not exist. Yeah, right. That's what we wanted. And so that would also be named, right? And then the other kind of error that we could get is that you tried to place, like for example, like the redstone repeater or something in an invalid position, like to the side of another block, um, which doesn't work. You can only do things like, you can only do that to things like torches. So while trying to place a component at a position, we found that the component wouldn't be able to connect. Yeah, that's the one. There we go. Okay, those are the three kinds of errors that we would want to throw. And then from here, we would just pretty much okay, I don't know why Copilot wanted to generate all that. Return RCL world gen. Error type. There we go. Okay. I see someone commented that they've been watching the channel. Dave, watching the channel since Blue Mix and Watson since 2016. That's very nice to hear. Thanks for joining. Actually, we can make this a match.
If I want to be able to just really easily print a vec, you could use the debug trait, like the direct debug or something.
Yeah, drive debug will automatically make it so you can print vecs.
Beauty.
Yep.
Yeah. I'm like more or less what I've been doing is very simple parser implementation using like the example code and everything, and they have this handy little serialized function that we can just avoid entirely by deriving debug.
Nice. Of course, happy to be doing this, Dave. This is the sort of thing I find really fun. So glad to see that it's been helpful. Okay, so I think Copilot pretty much got my get position logic in properly. And update block, we got the position in, nice. So then, I think the ownership of that does work out. So inside, now I'm thinking about like actual logic, from that standpoint. We probably just want to create the actual block export, and then the add this block to the world. So just like self.exports.push. Yep, we want the block type, we want the position, NBT, there's no NBT data, self.world, and then we would insert the component name and the position, and we can take ownership of the name from the component, so no memory copies because we are consuming the component, and then we can just respond okay, which is great. And then from here, we can do a match. Oh, the only thing is I think we need to make a copy of the, because if we do match component dot, I have to change instruction. Instruction permit, okay. State. Okay, so the reason this thing over here isn't as a panic and not an error is because no matter what kind of syntax you use in RCL, you should never be able to hit this point. This would prove that there's something wrong with the actual RCL logic itself. So attempt to use a block update logic with non-block primitive. We should never hit that. Should be okay there. If we match the primitive, if we hit RCL primitive block, then we're going to do self.update block component. So now the thing that I'm worried about is I think that this over here will either partially borrow or like it will probably partially move the primitive out of the I don't know if is that a thing? It's partial move Rust? Yeah, it is. Okay. So it's going to do a partial move of the primitive from the component structure into the match. So it can do this. And because of that partial move, Rust will think that this is unsafe even though it's not. Because this could have been effectively just a reference-based check. But even if I were to do this, it's still not going to work because I think First Soul will complain about me not doing something like this. But even if I were to do that, now it says that there's a immutable borrow, so you can't move ownership of it into the other function. But let's see if it complains, and if it does, what it complains about. So instead of instruction, we'll call it component, and we'll do mod component, and yeah, we'll do all of the renames. Okay. So, oh, wow, okay. I forgot to make those things public, didn't I? I wonder if I need to specify that all of the enum cases are public. I actually don't remember. See, that's also another thing, is that doing this also is a good demonstration of, like, in the real world, how much people don't know about programming. Like, so much stuff that we're doing here, we have to Google or ChatGPT.
Oh yeah.
Right? But it's like, it's not because we don't know what we're doing, it's because that's just how it is. Like, you never remember the actual logic. I mean, eventually do it enough and you will. But you never remember the actual like raw syntax and things. You're just thinking about what is the problem I'm trying to solve, how am I solving that problem, etc.
Yeah, definitely agree.
Primitive. Oh, it's core, not crate. Interesting. That doesn't seem right. Okay, yeah. So as I guessed, you do not need to specify that the enum cases are public. There. Okay, way fewer errors. Bimap doesn't exist. We can fix that by actually importing it, adding it as a dependency. Version 063. And then finally, fixing this typo, and then trying to figure out what in the world it means by it can't find primitive, because that should exist. Oh, it's component, not primitive. My apologies.
Yeah, I'm currently dealing with the same refactoring errors.
Oh, right, because there's nothing inside the enumeration. It doesn't need parentheses. And also that's a hash map, but it needs to be a bimap. And yep, there's the partial borrow error that I was seeing coming. The partial move, I guess. Let's see. Or this is the one at least. This is a different one. Interesting. Okay, so on line 94. Oh wait, it's only complaining about update block. It's not actually complaining about update. So maybe that other logic is okay. So it's complaining here that we do a partial move of the facing direction from component. But then that on line 98, I think, yeah, that we eventually move component itself when we can't move that. So we could probably solve that by just taking a reference to direction. That should be okay. Because I don't think that it matters. Okay, yeah, that's fine. And then here, it's also just complaining that on line 104, we use position, even though we move it where? 107? Oh, okay, I see. It's complaining that this position here is used both in the block export and in the world insert. So to fix that, we're going to clone it for the block export, which is okay because coordinates are tiny. As a matter of fact, I am tempted to just make this a copy by default structure because it's so tiny. I might as well. And so that way I don't need to say things like this. I think that should be okay. And like I can just like dereference that now. And I can also prevent needing to clone here. So it won't move. It's just always going to make copies. Okay, there we go. So that does work. And okay, now time for the moment of truth. Let's see if this works. So if we were to take world gen, if we were to do a use crates export RCO world gen, right?
I love Copilot. I understood that like the value that's attached to repeater is a ticks value. It's incorrect about the comparator though. Well, actually, is it?
What?
It's calling the value inside the comparator subtract.
That is correct.
Beautiful.
I love Copilot. Now, if only we could use it on proprietary code and stuff, that would be incredible. If only we could self-host Copilot. Okay, so
The way it jumps around when there's a code suggestion then is quite buggy. Well,
yeah,
maybe not buggy, but
that's why I'm usually not in insert mode in Vim, and I only go into insert mode when I actually need to be.
that's kind of true.
I always move around when I'm not in insert mode. Yeah.
That's a good idea. When we say on for comparative, that means subtract mode is on. Does it mean?
Yeah, it's in subtracting mode, is what it means. So I should probably just create a small implementation for the coordinate so that it has a new function also. Yeah, let's do that. Come on, Copilot, you can do it. There we go.
So,
And then
it's going surprisingly well.
nice. This can also be a reference. Actually, oh, I can't call a function move, can I? Move or apply. I can say transform. Yeah, as a matter of fact, I can even just do that. Like so. And then we don't even need the brackets. It's only messy because I have a V-split and I'm zooming in a bunch of the code. But inside the world.gen new, I should be able to do coordinate new of 0, 0, 0 for the sake of simplicity. Okay, so now I should be able to import coordinate as well. Which, does that come from component? No, it comes from exports. Okay, and then I should be able to do worldgen.update. Actually, I might even be tempted to just comment a lot of this out, and then for now, throw this in here. Whoops. And then take this and actually specify it as, oh my god, let and then update it with. Okay, let's see how mad Russ is about this. Unclose delimiter. How? Okay, I did not close my implementation block. That would make sense. Also, yep, I would need to make that part of the result enum. Honestly, might as well see if it works. Okay, so it doesn't trip any asserts or cause any errors immediately. Let's see if this works. So let's just make our main function return any error. So standard error, right? And then let's do that. Okay, so I just need to make it so that we implement the error type for the custom error, which is not hard at all. So I just do implement error RCL worldgen error, and I would also want to do a derived debug and a derived debug. I mean, I don't need all that for now. And oh, yep, also forgot to import. I think I'm just importing error. Oops. Oh wait, why is that on one line? That's not good. Cannot be formatted with the default formatter. Oh, I need to implement display as well, I guess. Copilot can do this. There we go. Yeah. So we'll implement better like error printing to do error printing. Mark my name down on that.
We are over time, but
We are a bit over time. Yeah, no, I kind of want to end this on a slightly better milestone.
Yeah, I'm getting pretty close here, so
Nice.
it'd be nice to finish off.
Yeah.
I've already got it compiling. I ran into a parser error, so it makes sense of how these errors work.
Okay, it looks like we also need to bring in formatter. Okay. Also need to add debug to here. And I assume to there as well. And last one, just gotta tell it that everything's okay. And there we go. We have a clean build, clean run, and we at least hit an error, which actually makes complete sense because I forgot to do this. I forgot to say that the root block exists by default. Wait, this is, not sure if this is stupid, but if you have an immutable variable in Rust, that means you have ownership over it. As long as you have ownership and it owns something else, can you call a function on it that needs a mutable reference to the thing that it owns? I don't think you can, because that would imply that you're mutating the larger structure. Let's see. So let world gen, for now we'll call it world, actually, yeah, world gen dot world. Yeah, I think it might force me to make it a let mute. Yep, okay, yeah. I always forget this because Swift has a feature that I am a really big fan of. And the feature is interior mutability, which is basically, it lets you say that, for example, hey, here's a structure, and within the structure there's 5 different fields, and these ones are variables, but this one's a constant. So even if you have a mutable variable that contains a structure, that one field in the structure cannot be changed still. It's still constant. I really like that feature because there's a lot of times where you need to have a mutable structure just because one field might need to change or update state, but the other ones are supposed to be there as constants and shouldn't change for the lifetime of the structure. But you just have to make the whole thing mutable in a language like Rust where that stuff can change. I guess theoretically what you could do is make it so that the fields are private and then you have getter functions, but that still means that within the actual structure you can also change it. In Swift, you could say that even within the structure, the interior immutability makes it so that you're not allowed to change the values. So that would have been nice to have in Rust, but I think there was even a proposal for it, but they thought it made the language too complex, so they didn't. We've already got ownership, but anyway. Okay. So now if I were to print the actual world gen exports and world, I think we should see meaningful results. Let's see. So I'm going to add the debug trait to that and also the debug trait to this. Try it out. Let's print. Whoops. We're going to print out. Actually, I'm going to put the logic for this in another function inside the actual world gen that we'll make public. We'll call it fn print state. So what this will do is just basically go through the world, print all the blocks that we know. And the other part of it is exports. All right, let's try this out. And of course, I need to actually run that function. There we go. Okay, so we've got the root block and we've got already an export, which makes sense. The export, well, okay, what did I tell it to do? I told it to make root block at the root position, which makes sense. The only thing that it didn't do is add root to the world state, or root block, I guess, to the world state. Why didn't it do that? It should have added that here, especially since it did add to the exports. Component.name. Yeah. Position. What happens if we print the state before we update? Oops. Oh, interesting. Oh, that is right, I guess, technically, since I didn't think about that. Because this is a bidirectional map, what happens is originally our mapping of root to 000 gets updated with the mapping of root block to 000 on the next version. So what I should do instead then is to keep the guarantee of no duplicates of coordinate to component name. I won't actually insert root into our exports by default, or into our world rather. Instead, there'll be special case handling for root position. So get position here. What we'll do is we will just check if relative to component is already just equal to root. Then we will just return the root coordinate transformed by whatever. Otherwise, we will do the match that we need to do. And we'll rename get position to, yep.
The underscore in a match statement is matching anything else that wasn't already matched?
Yes.
Yeah. Making sure.
Yep. All right. Let's see if this works. It does work. It's just that I forgot that we don't actually want the percents in the names here. The percents are for syntax, not for the actual resulting. Whoops. Okay, that's not what I wanted to do. There. Okay. Now, there we go. So we end up with the correct world state. We have our root block, and we have the correct export. And so we have the underlying foundations for what this RCL exporter would look like. Now we just need to go ahead and implement this logic for a bunch of others, and also implement better world input logic. Shiva comments, commendable, you guys are doing code straight for 2 hours with no water or movement.
About to just move. So that's a good call.
That is a good call.
I will be back.
Sounds good. Sometimes we go way longer than 2 hours, so thank you for the call for us to actually take a break. Okay. We're going to do one last thing to end off today's live stream. because I think it's going to be really interesting, which is get the air handling logic a little bit better, and then also attempt to actually, we'll do that in the next live stream. The next live stream will be us attempting to actually bind what we've done in with Python so we can generate an actual Minecraft world, but I think we did make good progress today. We may do a little bit of more work offline, just like adding extra functions for different kinds of blocks, but you see what the main logic is. We're not going to go too far off stream. Once Paul is back, we'll also take a look at where he's at with the parsing logic, just take a high level look at that. But apart from that, I think we are good to go for most of today's live stream. The only thing, once again, that I'm going to change here is the world insert. So we'll do a fn add export, and this will take mutable reference to self. It's going to take the export. We'll take the position. No, we'll take name and RCL and the actual export, which we'll call the block export. RCL block export. There we go. So that way we get to do the world insert with that data, and because we made the coordinate structure derive the copy trait, this just works. And so here now we would just do self.add export of those things, like so. I wonder if for RCL block export, we should just make a new function as well. For now, let's not do that. We can do that later. The only thing that's left is to do the air handling logic, because this needs to return a result of nothingness and RCL world gen error type. So basically, this is the only thing though, is that if we were to make it return this kind of error, then because we did the partial move of the name of the component into this function, we are no longer able to hold, we're no longer able to hold or use the component in the error that we eventually pass. So yeah, I guess we'll clone the name. I wanted to avoid that clone, but it literally does not matter for performance, so we'll do that. And the only reason we need that clone is because there's a chance we might come back and throw an error. So let's actually separate that into 2 lines of code once I get back to that. For now, though, let's verify. There we go. So if we already have... Oh, that's actually a really good point that I didn't think of. One of the pieces of error handling that we need is whether or not we're like maintaining SSA. Should that be in parsing logic or in like update logic, like of the world gen? I feel like that logic needs to be in
The parser. Like, I think there's an in-between stage there.
right, because for simulation, I feel like I'm putting too much logic in world gen right now.
Yeah, there's
Logic that would end up
that all that stuff you said about like verifying and everything. That's like an in-between stage. We parse the thing, then we run verification,
right,
like semantic analysis,
right.
and then we do the world gen once we know that what we have in our.
Well, that's the
internal
thing, is like
representation works.
because this is such a low level representation already, world gen is just like plus and minus on coordinate values. So like the way this is written right now is it does that plussing and minusing as like inside semantic validation. Because we're storing things anyway, we might as well just add coordinates, right?
Okay. Yeah.
Because the validation is what we would do at the same time for like generation. So maybe instead of calling this world gen, we would call this like, for lack of a better word, materialization. And then in materialization, we do error checking. And then once it's materialized, we can either simulate or export.
That works.
Yeah.
But that doesn't answer your original question.
Yeah, fair.
That's to say.
Because like the easiest way for me to verify that is just right here inside the update function to say, oh, if the name already exists in our exports, then just error
Probably
out.
do that.
Yeah, okay.
We can always revisit.
Yeah.
Error.
So we'll call this duplicate component name. Yeah, okay. Called duplicate component name, and we'll check for that error here. And then I see a great question from Sandy asking, how will this Redstone compiler be implemented within the Minecraft environment or other platforms? That's precisely the part of the challenge that we're working on right now. So we are trying to figure out how we can take this Redstone circuit language that we call it, bring up that diagram again, take that Redstone circuit language and export it to Minecraft worlds.
Yep.
So right now we're currently working on the parsing of that language, exporting it in. We're probably going to use a library like amulet over here. I have a little MVP here of how we can actually get information from a Minecraft world. It does work. We can also use the same API for setting data inside the Minecraft world. And as long as we can call this Python package from Rust, we're able to modify Minecraft worlds. So that's
for those of you that tuned in late, this RCL language that we're talking about is not by any means what we meant by compiling to Redstone. This is like compilation is really just a bunch of like translation steps. And really, the more complicated the compilation, usually the more steps you want to break it down into. This is the very bottom step. It's the one last level before we export directly to a Minecraft world. Allows us to abstract the ideas of Redstone away from what will be higher level concepts later.
Exactly. And so this just makes our next steps way easier, basically.
Yeah.
Where were we? Okay, so this double checks that we're not ever trying to add duplicate component name. Then we just got to check for duplicate positions. So contains right is what we want to check for. There we go. Well, okay. Does it build? Almost. Non-exhaustive pattern. Oh, right. Interesting. Oh, right. Yeah, if we didn't make this. Hey, I see someone's asking to describe the project a bit more. Give me one moment here. I'm just going to quickly.
Yeah, maybe we should finish off the stream with like a
overview
and like, kind of like what speculative ideas we have right now.
Right. I agree.
nothing's really set in stone yet. A lot of this is just wild ideas still.
Yep. Um, and there we go. So now we are in a much better spot for error handling overall. So we reached a pretty good milestone in exporting. Where are you at with parsing?
Just debugging.
Handling an error?
Yep.
Let's take a look at it. Maybe I can compile, recreate the error so folks can see it on stream.
Yeah, go ahead. So there was, it's a compiler error now. It was not a compiler error earlier. Right now
well, wait, you're editing?
Yeah.
Maybe quit it. I can try and edit it.
I mean, sure. Let's let you take over. I'll walk you through what's happening, but like, let's switch this to stream.
So what's happening here?
Okay. So I changed something to, you know what? Let's start at the beginning. Open up the other file, the pest file.
This one.
Yeah. I silenced RC1 because I was looking at a JSON example, and that's what they did, but I'm not certain if that's right. Let's try recreating the first error I got, which was a runtime parsing error. So
Okay.
remove the silencer from RC1.
Oh.
And
Whoops, sorry.
yeah, I'm just trying to back.
Where is
the silencer? Is that underscore? Yeah.
Yeah.
It just means it doesn't produce any tokens.
Okay.
But I don't have a good understanding of what that means really. Try cargo running this. I'm wondering if there's any other changes I made. Was there? Yeah, there was.
Doesn't
Okay.
this need to be like pairs.iter or something?
I don't remember. What was the code before? 1 second. Now what changed was the other change I made was I added this next unwrap thing. It's just a question mark before.
Oh, well, yeah, the next would make it so that like you're getting a value from the iterator. That wouldn't work.
Yeah, okay, so just delete that for now. Yeah,
yeah,
okay, this should reproduce the error now.
Okay.
Yeah, so there's the error. It has something to do with reading
unsuccessful parse.
Can we start, maybe go to the example and just remove the comment line?
The example. Okay, so
So
we'll
examples.
Just remove it.
Yeah. Okay, so it's not related specifically to that.
Right. Okay, so what I'm curious about is to see if we took this, right, and we went here.
Good start, good start.
Right? Here's a grammar I defined for a custom language using Rust's passphrase. And here's a sample file I'm trying to parse. I'm getting this error.
Hacks.
Can you help me figure this out? All right, let's see. Remove the requirement for a new line. I don't think that's the error because we have new lines after
Plus
that.
we tried without the comment.
Right.
Also, if you do look at the main.rs file, it stops before the second print statement. So we never even get to the
right. Like it's failing here.
Yeah.
Right. Love using prints for debugging. What's rule RCO?
RCL is the overarching rule.
Like strategy for parsing, I guess.
If you go to the pest file, it's the overall
Oh, okay.
file. Yeah.
Oh, interesting.
Yeah. So it would be
Ah.
the whole module, I guess.
So it like compiles it into
Yeah.
nice. Okay, I like that. What's the exact error we're getting? Kind of saying unsuccessful parsing error.
Apparently that positives thing into documentation meant that like it let me double check. Positive attempts. Yeah, so that means that that was a positive attempt at parsing that rule, which is weird. Oh, no. That doesn't mean like successful. It means positive as in like we're matching it literally. We're not matching the negation of it. I think.
Interesting.
Or at least we're trying to match it and failing to do so. Okay, you know what? Which thing? Hmm. So it seems silencing RCL doesn't help us in anything. Doesn't do anything different. I don't know if it's correct behavior or not. I don't. You have a better understanding of silencing than I do. Let me know. But
let me see.
Silencing, as far as I see, just doesn't produce tokens or pairs, which is
Let's just throw some.
We don't want a token or do we? All right. Let's get you on the same page.
Okay, well, once GPT gets through its reinforcement learning driven need to explain literally everything.
I think you understand most of them. We just like ask for
Right.
syntax.
Yeah, that's pretty much all I'm caring about right now is just the syntax. Start and end of input for SOI UA, that's obvious.
Yeah.
Tilde is sequence, makes sense. Star is repetition. At is the atomic rule. What's the atomic rule operator?
That one other one that wasn't so like those two are the ones that like are like, kind of like, confusing.
Atomic rule produces a single token regardless of what it contains. So the internal structure is not recorded, only the span of the entire rule. That makes sense. So it's like this, like if a bunch of ASCII digits, it's not going to separate like 1, 2, and 3. It's going to be one thing, right?
I figured it was honestly something like that because the word atomic.
Is that the name for it? Silencing operator?
Yeah, or silencer or something. Either way, I'll find it. It's ChatGPT. Yeah.
When successfully matched does not produce a token. Oh.
If list matches that, it will produce a single token. Yeah. So yeah, so we don't want a token produced for all of RCL.
Right.
So RCL should be silent, and then the individual components are not silent. And I believe that matches what is currently in the file. Do I have it open? Hold on, let me close it. Okay. Yeah, so RCL is silent, and then component is not silent, which I think sounds right.
Okay. Well, right now, what happens if we run?
Same error, regardless of whether we silence it or not. Because I don't think it gets that far.
I think there's something about the actual RCL like past file that might itself just be wrong.
Like, you think there's a syntax problem?
Yeah, maybe a syntax problem or just like a logical issue with something. how about we start with like a much simpler version of this? So let's
Yeah.
modify the example. I'm gonna move the example to like. Did you mean to say and, not add?
Yes.
It's
And it's very funny because I made the mistake in the main.rs file too.
whatever. Keep it add. So let's just see if we can parse a comment.
Okay.
So let's see. Write a pest grammar to parse a file of comments, each parse a language. Let's start with comments. I hate how you have to like speak so conversationally with GPT for it to be good, but let's start with comments. Comments are defined by a semicolon. Comments begin with a semicolon. Write a .pest file.
If someone in the chat asks if we work at Microsoft since we're working on Minecraft. We neither work on Microsoft or Minecraft. We're building something for fun that is on top of Minecraft. Neither of us have seen Minecraft source code ever.
Unfortunately, we have not. Maybe fortunately, actually, because I have used the modding
Because it's in
package
Java.
and there. Okay, I'm gonna move rcl.pest to like bold RCL.
Sure.
Okay, let's see if we can at least just parse the comment.
So are those lines the same? Okay.
I'm just gonna like also comment out like
Yeah, there's a lot of stuff here that cannot run right now.
And maybe even just as a matter of fact, actually, maybe even just parse out this whole function and just like in the main do a quick to yeah, let's see if we can do that. Doesn't see rule RCL.
Because you removed it, remember?
Did I?
From the pest.
But I made a new one. RCL.pest.
Yeah, there's no RCL rule in there though.
Oh, that's a really good point.
RCL is comment.
It'll probably.
Yeah, something like that. Or any. Why would they do that? Comment or any.
Any character. Well,
but that's bad.
That's a good point. I can just remove that from the grammar.
Would not recommend.
Yep. Like that?
Yeah, that looks like what I expected to be.
Okay. So now if we do a cargo run, okay, it doesn't throw an error. Can we get it to like actually print something though? Okay.
I hate it. Okay,
all right, it does
fine.
in fact work fine.
Okay.
Now let's extend it a bit. Let's see. Here's an example of some statements in my language. The language, valid code in the language consists of only a series of these statements. They are all assignments to variables. Variable identifiers start. All statements are assignments to variables. And then the statements, the variables are assigned the results of primitives. The primitives may or may not take arguments in angular brackets. The following each primitive is a variable name that there is another variable name that the primitive connects to, as well as a direction follow a comma and then a direction primitives. Okay, and then we can list them out again. So there were what? Dust, torch,
Repeater, comparator, buffer, lamp, block.
Block. Great, and then repeater is takes. Two, three, four. Direction. North, south, east, west. Syntax. Right, good point. Okay. And now we can throw in the AND gate.
Add the add gate. And the null value for
Fair.
wait. Hold on. What if like that was the error? That couldn't be it, right?
There's no way.
No, because we would have got a better error.
Yeah, we would have gotten a better.
They would like it would
Yeah,
have
I refuse to believe that that was the issue.
If so, we were using a really bad library.
Yeah.
Yeah. But we should. I'm gonna fix that in the end.
Yeah, thank you. Yeah, I'm just gonna make this repeater. Yeah, okay. Oh, I did the repeater logic pretty smart this time.
Ah, that's nice.
Yeah.
Slightly better than what I had. Yeah.
I think that's actually a lot.
Yeah, it's
like,
better. It's better.
Cleaner.
Yeah.
Okay.
Well, let's try this one.
Maybe this one works.
Well, we have a bunch.
Okay.
Oh, okay.
So now if we start to throw some more code into it, what if we did like this in
Well, our parser function doesn't score anything else yet, but like, yeah.
Oh, right, but we're not calling that yet.
Right.
So we're fine.
That is true.
Okay. Panicked. Expected primitive. Oh, I didn't put block as a primitive. Whatever, I can modify that myself. Oh no, block is a primitive. What the hell? Expected primitive. This is a primitive. Block is a primitive.
Is it because of the space? It's because of the space.
I wonder if
It's we didn't
This
remove we didn't pre-process to remove white space.
Are we supposed to?
Like, ideally we do that ourselves.
But then white space in comments. The parser is supposed to deal with white space.
white space and comments in a traditional compiler are removed before we get to the parsing step. Like everything is tokenized.
Fair.
I understand this is a bit different, but I don't think I want to deal with white space in a parser.
You're fair. Okay, that you're not wrong. You're not wrong, but
Because like, look how ugly this is getting now. We do not need 4 white spaces in like every grammar.
that's a really good point, actually.
Okay, so we need a preprocessor, which we completely forgot about right now. So right now.
Okay, let's just see if this makes it work. It does work.
It was the white
Okay.
space. Oh, I forgot us. Well, okay. We can just, before the parse function, we have a preprocess function, just wipes any rules that are comment or white space. And
But that means we need to start by parsing out.
yes. How did this JSON example work? JSON has white space.
All right, thanks for joining us, Dave. And yeah, this is an exercise as we mentioned in showing like what real world development looks like, right? So that includes all the way from like coming up with the creative architecture and logic around how we even do this to, in implementation details and thank you very much, Dave. And yeah, it's really interesting to see how this sort of thing actually works. But yeah, I think to be fair though, for today's stream, I think we've reached a really good point, right?
That's
So
fair.
we have the ability to parse, even though we don't like the way we do it right now and we'll probably change it around a bit. We have the ability to do world gen, like we have the basic rules in place. We have the ability for semantic analysis. We've even made sure that we can theoretically interact with the Minecraft world files. So for RCL, I think we have all the building blocks in place.
Yeah.
Right. So now it's all just about tying all the pieces together, finishing some rough edges and then getting there.
You think it'd be a good idea to like touch up this stuff off stream?
Yeah,
So that
absolutely.
next stream we can start
Yeah,
a fresh
yeah,
topic.
yeah, agreed. So next stream we'll be starting off like with a much better RCL foundation. So you got to see us actually work on the core pieces. We're gonna go ahead and just like do some fine tuning off camera.
Now, I don't think we've talked through what the parser code is doing at all, really. We just
Right, that's a very good point. Yeah.
That's
Do you want to walk us through?
Yeah, I can do that. Yeah, uncomment this stuff just for syntax highlighting, even though it is broken. It's like it's mostly functional. There's just a couple things that are just not there yet. So if we start at the top, these structures here are for like the internal representation of our RCL code. So every RCL file will turn into one of these RCL modules, which is just a vector of RCL components. And if you've been following along, the components are each of those assignment lines of code. Essentially, that's all that RCL is just a list of placements into the Minecraft world. We chose to call them components after some, whatever the word is, debate. So every component made up of 3 things. We have the primitive, that's the actual Minecraft item, block, whatever that is being put there. The relative to is, as described, we have another pre-existing component that we have already defined, and everything else is just relative to that, with the first component being the root, which is added by the compiler or whatever we want to call this. This isn't a compiler even. And then everything is built off of that. And then everything also has a direction that's facing inside of its location. Yeah, I think the enums for direction primitive are self-explanatory. Then so if we look at the main, okay, our main's all over the place right now, but the idea is in our main, we're just calling this parse RCL on a file where we have some RCL example code. And in here, the basic idea is we start by parsing with this one parse rule that's just called RCL, and that's just making sure that the hold on, how can this return anything if RCL is silent? How does that work? I don't think RCL can be silent. If if something is silent, it doesn't return pairs or tokens. We're just validating it or not.
Right.
So I guess we should change that. It shouldn't be silent because
Is it currently silent? Hold on.
no,
No, it's not.
Yeah,
It's
in this
not.
example, it's not
Yeah.
silent anymore. That's fine. Okay. Yeah, so we're parsing just the RCL rule, which is for the entire RCL file. As you can see here, if you've been following along, there's some syntax here that's hard to read, but it's basically saying that every RCL file starts with the start of the input, and then sequentially followed by, and then either a comment or a statement, and then that star means any amount of those, 0 or more. So in theory, you could have an empty file, followed by sequentially the end of the file. So pretty straightforward. It just means start reading the file, read 0 or more comments or statements, and then end the file. And then comments are just any line that starts with a semicolon, followed by anything other than a new line, because the new line is what we use to find the end of the comment. And then statements, well, okay, this is ChatGPT output. We won't be calling a statement. We'll be calling it a component. And component is that thing where you have a variable name followed by equal sign and the primitive and the direction. Yeah. I'm not going to go into too much detail because if you've been following the stream, a lot of this has been covered. What else? Okay, so when we get here, we start looping through the pairs that are returned from parsing that RCL rule, which should return a bunch of, yeah, it should return pairs. I'm not even really certain about some of the details here, but we're matching what type of rule each of the expected pair types is, and it's going to be like one pair for every line of that we're reading inside of the RCL that we parsed. So you can see here we're matching the types we expect. We expect components, we expect comments. Well, we expect comments, but right now we're just choosing to do nothing on comments, and also on the end of line, which I end of input. I don't understand why every example I look at, like EOI is a rule, but SOI is not.
Interesting.
I've tried adding SOI here and it tells me it's just straight up not a thing.
Maybe because SOI is just always implied.
I guess, but
Like you always start
yeah.
with SOI, so.
Yeah, okay, fair. Yeah, so next steps, in order for this code to work without it getting weird and messy, we need to run a function before this that does pre-processing that would remove all the white space characters so that our grammars don't have to look ugly like this.
Yeah.
And also so that
how do we get it to ingest it though then? Like,
yeah,
how do we?
I have to look into this more. I'm not sure how to remove white space from the thing
while also allowing it to still
continue.
like parse,
yeah,
right? Because
because
it's taking a string.
There's a way to do it. We just
we just gotta maybe
we just go back to a string. Maybe we don't even use white space in the part with like a parsing library. We just loop over the string, remove every white space character in a very simple way.
Yeah,
and then run the parser on it.
Yeah, honestly, as long as it has a thing that lets us pass it tokens instead of why does it take only a string? Okay, we'll see. This is a later problem. Yeah. The point is we have the actual core.
Are we gonna do the preprocessor off camera? It's really
probably
simple.
Probably it's extremely.
We're
simple.
just removing white space. And, honestly, we could leave comments in. We don't even have to pre-process comments out at the moment. We can figure that out more later, but for the moment, like we
literally just white space.
Comments, but we just don't want white space in our grammar. It's just really ugly when that happens.
Right. Yeah. Makes sense.
Yeah.
Wonderful. Okay. And I guess that pretty much concludes our first stream.
Yeah.
Wonderful. So thank you for joining us, everybody. This has been a little bit longer than we expected, but hopefully you enjoyed. I know I am definitely having fun.
Yeah, that went much more smoothly than I could have expected, but I guess that's what happens when you use Rust instead of C++. So I'll take it.
We actually got to write code instead of writing CMake
We
files.
actually got code to compile.
We actually knew how to download our dependencies.
I didn't see a single segfault today.
The only panics we had were ones that we coded, so I'll take that as a win. But yeah, thank you very much for joining us, everybody. Thank you for joining, Paul. Great to have you on, and I'm looking forward to this and to our next stream, which you will hear more about on social media right as we plan it.
Right, yeah, we don't have any plans yet for that.
Right, we don't have an exact date and time in mind yet, but we will soon.
It'll be soon.
You'll see it on social
We
media.
should try being a bit consistent with.
Yeah, we
Yeah,
should. We
we'll
should.
figure
We'll
that out, though.
probably make it a schedule.
Yeah.
All right. Thanks, everybody, and we'll see you in the next part. And once again, any more questions or suggestions, feel free to leave it down in the comments. Right as we have this on a GitHub repo, we'll update the description of the video, and we'll see you next time.
Bye.
Bye bye.